Hi guys, this is part one of the particle physics official lecture. I'll post the blank PDF document for you to record your notes on. And I will post this in probably 3 sections because we're looking at sections 1, 2, and 3 of chapter 30. We have a laundry list of vocabulary. This is not part of your lecture notes, but I just want you to be aware of these vocabulary words. They are highlighted in bold print in most of the lecture, and I'll try to be very clear when you encounter a vocabulary word. So our first section is about the structure of the nucleus of atoms. Atoms consist of a dense positively charged nucleus that is surrounded by an electron cloud. We've said this a few times before, and you probably remember it from previous science classes. That dense positively charged nucleus is itself made up of positively charged protons and neutrally or uncharged neutrons. The protons and neutrons are collectively referred to as nucleons. So a nucleon is either a proton or a neutron. That's one of your vocabulary words. The number of protons in the nucleus is called the atomic number, and the number of total nucleons in the nucleus is called the mass number. And those two numbers help us identify isotopes of an element. The mass of a single proton or a single neutron is about 1 atomic mass unit, and an atomic mass unit is a mass equal to about 1.66 times 10 to the negative 27th kilograms. So we tend to not really find the mass of a particular atomic nucleus or a nucleon. We usually don't worry about such small units, or we don't try to think in terms of such small units. Instead, we try to think in terms of atomic mass units or units of numbers of protons or neutrons. So the total charge of the nucleus is equal to the total charge of the protons in the nucleus, which would be the atomic number of protons, times the amount of a single charge, of a fundamental charge. The charge of an electron is the same as the charge on a proton, and that is defined as the fundamental unit of charge. Even though quarks have parts of charge, fractions of charge, they don't exist on their own. So we define fundamental unit of charge as charge of an electron or proton. The mass of the nucleus is approximately equal to the mass number times 1 atomic mass unit. As I said, it's hard to keep track of such very small amounts of kilograms, so we tend instead to worry about numbers of nucleons. I'm ignoring my phone for now. I don't know if you can hear it ringing. So all of that leads us to the idea of isotopes. Isotopes leading us to the idea of atomic nucleus instability and then radioactive decay. So recall that an element can have more than one isotope. You might not recall, this might not be part of your background knowledge, but atoms of a particular element are defined by how many protons they have. So all atoms of a particular element have the same number of protons. The protons kind of determine the chemical characteristics of the atom. However, nuclei of a particular element can actually have different numbers of neutrons. You can have the same number of protons and different numbers of neutrons and still have a stable or relatively stable nucleus. As I said, all isotopes of a neutral element have the same number of electrons as protons, and they behave chemically in the same way. A special method of notation is used to describe an isotope, where you give the element symbol in large print, and then to the left and top, you indicate the mass number. So you remember that that's the total number of nucleons, protons plus neutrons. And then on the bottom left, you give the atomic number, the number of protons. And that element symbol and atomic number are always coordinated. If it's carbon, then the atomic number Z is always 6, whether it's carbon 14, carbon 12, or some other isotope of carbon. Carbon 14 would be a mass number of 14, and it would have 14 nucleons, which means 6 protons and 8 neutrons. More about isotopes. Most elements have several isotopic forms that occur naturally. They have several variations of a nucleus of same number of protons and different amounts of neutrons. The atomic mass listed in the periodic table is the weighted average of mass of the naturally occurring isotopes of the element. While the mass of an individual atom is close to a whole